In this lecture, we will be studying about system calls. So we will be trying to understand what are system calls and what are they used for. Now it says here that system calls provide an interface to the services made available by an operating system. So we know that our operating system provides us with certain services. Now the system calls, what they do is they provide an interface to the services that are available by the operating system. So before we try to understand system calls in a more detailed way, there are two important points that we need to know about, which is the two modes of operations in which a program can execute, which are known as the user mode and the kernel mode. So let us try to understand what is this user mode and kernel mode. So this user mode and kernel modes are two modes in which a program can execute. So if a program is executing in user mode, then that program does not have direct access to the memory, to the hardware and such resources. But if a program is executing in kernel mode, that program has direct access to the memory and hardware and such resources. So we say that if a program is executing in kernel mode, then it is in a privileged mode because it is having direct access to many of the resources. But the problem is that when a program is executing in kernel mode, and if that program happens to crash during its execution, then the entire system would crash or your entire system will come to a halt. So that is one problem of kernel mode. But if a program is executing in user mode and if it happens to crash, then the entire system does not crash or the entire system does not come to a halt if the program is executing in user mode. So user mode is a safer mode of operation, though kernel mode is a privileged mode. So these are two modes of operation in which a program can execute. So we see that user mode is more safe, and because of that, most of the programs they execute mostly in user mode. But when a program is executing in user mode, it may need access to some of the resources like your memory or your hardware and so on. So when the program needs access to these resources, it makes a call to your operating system telling that I need access to certain resources. So it makes a call. And when it makes that call, what happens is that for an instant, the program is switched from user mode to kernel mode so that it can use those resources. So there is a switching that is happening. So when a program switches from user mode to kernel mode, that is known as context switching, and even when it switches back to user mode from kernel mode, that is also known as context switching. So when the program makes a call to the operating system saying that I need to use this particular resource, the context switch happens where the user mode is switched to the kernel mode so that the program can use those resources. And then the call that I was talking about, the call that the program makes in order to access those resources or to go into kernel mode, that call is known as the system call. So we see that system calls are made by the programs when it needs to access certain resources. So when a program executing in user mode needs to be switched to kernel mode for a particular time, this system call is made. So this is one way in which we can understand system calls. So we can say that system call is a programmatic way in which a computer program requests a service from the kernel of the operating system. So this is what I already told you. When it wants to request a service from the kernel of the operating system, the service could be anything like accessing some resources or something like that. So a system call is made for doing so. And these calls are generally available as routines written in C and C++. So this is the way we can define a system call. Now, in order to understand in a more clear way, let us take a simple example in which we will see how system calls are made and how system calls are used. So let's say that we have a simple example here where we want to copy the contents of one file to another file. So here we will see the example of a system call sequence for writing a simple program to read data from one file and copy them to another file. So here we have a source file and we want to copy the contents of this source file to the destination file or the output file. So we will see how the system calls are made for this simple task. So here are the first sequence of system calls that will be required. So first of all, in order to copy the contents of an input file to an output file, we need to get the name of the input file. we need to know which is our input file from which we are going to copy the contents. So the first step is to acquire the input file name. So we need a system call in order to acquire the input file name. And then we write a prompt to the screen. That means you are displaying a prompt on the screen asking the user to enter the name of the input file. So for writing the prompt to the screen, you need another system call. And then you need to accept the input that the user gives you. So for that you need another system call. So all these boxes, they represent individual system calls. Now let's start from the beginning again. We need to first acquire the input file name. So for doing that, there are two ways. One way is we can ask the user to enter the name of the input file. Otherwise, in the second option, we can display the files that we have in our system, and we can ask the user to browse through those files and select the input file using his mouse or other clicking or pointing devices. He can just select the files. So in either way, for acquiring the input file name and for writing the prompt to the screen, that means asking the user, please enter your input file name, and for accepting the input, we need system calls. So as I told you, system calls are made when we want to access some resources of your system. So for acquiring the input file name, we need a system call. So for writing the prompt to the screen, you know that you have to display the prompt on your screen, on your monitor. So you're going to use the hardware, your output device. So you need a system call for accessing that hardware. And then for accepting the input, you need to take the input using either the keyboard or the mouse. So your keyboard and mouse are the input devices. For that also you need a system call because you are accessing the hardware, which is your input devices. Alright, so these are the first three system calls that are required for this process. Now after we have got the input file name, we need to get the output file name. That means the file to which we are going to copy the contents, this destination file name. So for that we need to acquire the output file name. So for that also we need a system call. And then we have to write the prompt to the screen. That means you have to display on your monitor asking the user, please enter the name of your output file. So for that, to display that on the screen, you need a system call. And then we need to accept the input. That means when the user enters the name of the output file using his keyboard, you need to accept that input. So for accepting that input, you need another system call. Alright, so moving on. Now we got the input file name and also we got the output file name. Now what we have to do is we have to open the input file so that we can start copying the things from the input file. So for opening the input file, you need to access the input file which is there in your memory. So for that you need another system call again. Now if the file doesn't exist, then you have to abort. So there can be errors that can occur. There may be a case that the input file that the user entered does not actually exist in your system. So if that file doesn't exist, then you need to abort. You need to terminate your execution. Even for doing that also, you need a system call. Now in the same way, you have to then create the output file. So the output file name that the user entered, you have to create an output file using the file name that the user entered. Now, if the file exists, then also you have to abort. Why? Because you are trying to create a new file into which you are going to copy the contents of the source file to the destination file. Now the name of the output file that you provided or the name of the destination file that you provided, if it already exists, then you cannot create that output file. You have to create a new file. You are not allowed to create a file that already exists. So if you find that the file already exists, then you have to abort. So for that also you need a system call. So for creating the output file, you need a system call. And if you find that the output file already exists, so if you find that a file with the same name already exists, then you have to abort or you have to terminate your execution. So even for that, you need a system call. So moving on, we were over here, and then now let's say that the input file that you provided, it exists, and the output file that you provided, it's a new file and there is no other files with that same name. Let's say that everything is fine. So now you are ready to write the contents of the input file to the output file. That means you are ready to copy the contents of your input file to the output file. So for that, you need to run a loop. And why are we running a loop? because we have to copy all the contents of the input file to the output file. So we start reading from the input file and we write to the output file. So this is the copying process, and this is a loop which runs until the read fails. So until read fails means until there is nothing left to read. So you have to keep copying and keep writing it until there is nothing left to read from the input file. Here also there can be errors that occur. So if there are any errors that occur, like hardware errors or anything, at that time also you may need to abort, and even for that also you may need a system call. And of course, for reading from the input file and for writing to the output file, you need a loop of system calls over here. And after everything is copied from the input file to the output file, you have to close the output file. So for closing the output file, again you need a system call, and then write completion message to the screen. That means you have to display a message on your screen saying that the copying process is complete, so that you can let the user know that the copying process is complete. So for displaying a message to the screen also we need a system call, and then we terminate normally. So even for terminating normally also we need a final system call. So here we see that just for a simple task like copying the contents of one file to another file also, we had to run a lot of system calls. So we see that many system calls were executed in the process. So we see that even for simple tasks there are lots of system calls involved, and we may keep in mind that there are thousands of system calls that are executed per second during the execution of certain programs in your system. So system calls are always being executed. So I hope you could understand the meaning of system calls and how system calls are used for performing certain tasks in your system. So now you must have understood how system calls provide an interface to the services made available by the operating system. So all the services that are there in our operating system, those services are made available to the programs by using these system calls. So the program gives a system call whenever it needs to use any of these services or resources. So I hope you understood the meaning of system calls. With that, we'll be discussing more about system calls and the types of system calls in the coming lectures. So I hope this was clear to you. Thank you for watching and see you in the next one.